Hello everyone, this is Osman Imam. Welcome to my channel Need to Know. In this video, I'm going to tell you what you would need to know about the technology of solar farms. Solar farms refers to a solar energy project that produces solar power in an order of more than 1 megawatt, scaled as utility connected system. While less than 1 megawatt, commercial or residential sites are scaled as grid connected systems. Solar energy refers to the electric power that is converted from a direct sunlight by photovoltaic effect using solar modules. This figure shows the solar radiation coming from the sun towards the earth. Some of this radiation is reflected back to the space when it reaches the greenhouse gases cover. And a portion of it, or most of it, penetrates the greenhouse gases cover and reaches the Earth's surface. Then it is reflected back to the greenhouse gases cover and returned again back to the Earth, trapped bouncing between the greenhouse gases cover and the Earth's surface, causing the global warmth. And another portion of it is converted by the solar modules to solar energy usable for the human. This is global solar irradiance map. Solar irradiance refers to the power per unit area received from the sun in the form of electromagnetic radiation. The dark brown colors are for the most highest irradiance. Configuration of solar systems. Solar systems are configured as on-grid and off-grid systems. Off-grid systems that are not connected to the grid, composed of solar panels, inverters, charge controllers, batteries, switches, production devices, and wiring. Off-grid systems are advanced, remarkable in design, size, weight, and prices, but still more expensive than on-grid systems. Areas where a big advancement witnessed on the off-grid systems are batteries. Lithium batteries achieved a noticeable increase on weight to power ratio and competitive prices, which would soon shelve the lead acid batteries. Inverters and MPPT charge controllers are integrated on one package, all in one packs. With inverter, MPPT charge controllers, lithium batteries, all packed on one pack, and all in one packs are introduced, like this one on the figure. Stackable power range is about 5 kilowatts up to 200 kilowatt hours. For commercial sites, another new EES is introduced. It is like all-in-one but in a big or large size. With power range 1.3 megawatt, can be grid connected, but a PPA is required between the producers and the grid owners. Some countries restricts grid connection to a minimum of 20 kilowatts for residential sites and a minimum of 5 megawatt hour for commercial sites. But still, it remains a high cost due to the presence of the batteries. This is an example of a solar farm composed of mounting, fixed or tracking, array, DC buses, skid pad, where inverters, meters, meteorological station, controllers, and transformers are located. AC buses, smart meter, substation, industrial load, monitoring and control, and then fixed or connected to the utility. A solar array is composed of a small piece, a solar cell called wafer. Then a multiple number of wafers composes a solar panel. And a multiple number of solar panels make a solar module. Then a multiple number of solar modules make a solar array. We must note that a solar panel is composed of 46 or 64, 72, 140 solar cells, and a module is a multiple of number of solar panels, while an array is a multiple number of solar modules. Solar mounts. They are made to give a strong structural support and keep orientation of the solar panels. They are generally made of anti-corrosion materials like aluminum or aluminum alloys or galvanized steel. They could be ground mount, fixed or moving, and sun tracking, or rooftop mount. Fixed facing geographic north or south relative to the location of the farm on the northern or the southern hemisphere. Oriented with azimuth and tilt angles according to the geographical location. Fixed mounts. They look like this. Fixed mounts ensure the module's fixing and support, as well as array orientation. They are strongly fixed to the ground. Rooftop mounts. They look like this. Sun tracking mounts. They could be a single axis or dual axis, depends on the design. Much space is needed to avoid shading. No livestock near. Although a single axis can increase the yield by 27%, and the dual axis can increase by 42%, but still remains more costly than fixed mounts. Combiner box. To minimize wiring DC and ease maintenance, a combiner box is added to connect the strings of the array on one side and with the inverters on the other side to provide early protection devices. Inverters. Inverters convert DC generated by the modules to AC. They are arranged in string or central configuration. String is best for utility systems. The power plant's AC capacity is usually defined by the sum of all inverters' AC capacities. MDAS, Meteorological Data Acquisition Station. MDAS is a weather station comprised of a calibrated high accuracy meteorological sensors, a data logger, power supply, and a communications interface. It is composed of anemometer and wind direction. Solar irradiance sensor, rain sensor, snow sensor, temperature sensor, a power plant and communication interface. Skid pad. Skid is a structural steel container on which solar equipments are mounted. It is a pre-assembled and often include multiple components in a single unit. The following equipments are located: inverter or inverters, meters, met station, controllers, transformers, and SCADA control panel. It is mobile to ease access and locating. A pad is a concrete platform for the skid. SCADA. SCADA is a supervisory control and data acquisition. SCADA is an integrated set of software, hardware, networks, and control substations or subsystems that work together to provide real-time visibility and control of the plant. It is a centralized system that monitors and controls the entire plant. This supervisory system gathers data from the plant and sends the control and command to the plant. This is a typical substation which serves as a point of interaction or interconnection between the utility and PV power plant, collectively called substation. Main transformers, capacitors bank, SCADA systems, intelligent electronic devices, grid controllers, set points, and automatic voltage regulators are placed. And this is an example of a solar farm. World top 10 energy producers, solar energy producers. China with 584 terawatt. We must note that 1 terawatt equals a trillion of watt. USA 238 terawatt, less than half of what China produces. India 113 terawatt, less than 1/4 of what China produces. Japan 110 terawatt. For Japan, if we look at its location on the global irradiance map, we must say, well done, Japan. Germany 62 terawatt. Brazil 52 terawatt. Australia 47 terawatt. Spain 45 terawatt. Italy 31 terawatt. And South Korea with 29 terawatt. Then South Africa, Egypt, Morocco, Algeria, and Senegal contribute with 57 gigawatt. Energy production cost 0.049 US dollars per kilowatt for solar energy, 0.033 US dollars per kilowatt for wind energy. Wind and solar production costs are with a 29% less than the fossil fuel power plants. Conclusion: solar energy is a free renewable energy potential resource. It is cost, infrastructure cost renders many countries to benefit, but it is very low running cost. High revenue is encouraging. Some countries like Japan and Germany made a big breakthrough compared to their geolocations and areas, while other countries with wide areas and the highest solar irradiance did not. Many countries encouraging residential grid connected with tempting PPA. Solar farms are the future of solar energy and safety of the global warmth. Well, if you like my video, please give me like, share, and subscribe. Thank you.